Hi. Hi, here we are for Honors Physics, doing Electrostatics Worksheet 3 on Coulomb's Law. And we are now to question number 6, which says, a young man that accumulates a charge Q1 of 2 times 10 to the negative 5 coulombs while sliding out of the front seat of a car. His girlfriend, who's been waiting in the wind, has picked up some extra electrons and has a charge Q2 of negative 8 times 10 to the negative 5 coulombs. Draw a sketch, estimate the magnitude of the electrical force of each person. If they are 6 meters apart, is the force attractive or repulsive? And you say, they say they want you to estimate the force. That's interesting. What does that mean? Let's take a look at this. Oh, I suppose I should get rid of the old problem, huh? Although it's going to be very similar now, isn't it? Here we go again. You say, we were taking a look at a guy. The guy goes ahead and he's sliding through 2 different materials, sliding past each other. One of them is a little better at attracting electrons than the other. In this case, the seat of the car is better at attracting electrons than his clothing, and so electrons transfer from him to the seat of the car. He becomes charged positive because he's losing electrons, and so he gets a charge of 2 times 10 to the negative 5 coulombs. So here we go. So, I don't know, what do you want? So he just slid out of the car, and so now he's standing here, right? And yep. All right, good enough. Whoa, what is going on there? I don't know what's going on there. That's not there. That's better. Okay, anyway, point is, you say, hey, he's now charged up positively, and that positive charge on him, we say, hey, that's 2 times 10 to the negative 5 coulombs. Is that right? Yes, it is. Okay, now, meanwhile, his girlfriend who's been waiting in the wind, you say, hey, she's got a force on her of, she's picked up electrons from that breeze and wind kind of brushing past her, 2 different materials, and so she's charged negatively, and we say that her charge is negative 8 times 10 to negative 5 coulombs. And they tell you that they're going to be roughly 6 meters apart. And it says they'd like you to estimate the magnitude, so that's like the nearest power of 10, the magnitude of the electrical force between them. And so you say, okay, let's do this. Fe is K, Q1, Q2 over R squared. If I just do power of 10 estimates, K is 9 times 10 to the 9. That would be roughly 10 to the 10. Yes? Okay, the charge is negative 8 times 10 to the negative 5. That's like 8. That's going to round up. So it'd be like 10 to the negative 4. And then this charge is going to round down, 10 to the negative 5. Notice I'm just doing 6 squared. Do you want to say 10, 10? Say it's 10 to the second? Round up, I guess. Okay, so if I do that, and remember that distance is going to be squared. Now we do the order of magnitude estimate, and we say, hey, to the 10th power, to the negative 4 to the negative 5, that's 10 to the first, and then this will be over 10 to the 4. It'll be approximately 10 to the negative 3 newtons. Okay, and I didn't need to use my calculator. I just did a real quick rough order of magnitude estimate, just using powers of 10. Rounding each one the nearest power of 10, cranking it out, gives you a real rough estimate of what that force is going to be like. Now, we could plug those values into the equation, get an actual value, but they just want order of magnitude estimate. And so we're getting roughly, around 1,000th of a newton would be the rough estimate. Unless I've made a mistake here. No, it's not going to rain. It's not going to rain. All right, I'm first, right? And then to the 4. Wait a minute. This was 10 to the first over 10 to the 4th. I'm going to subtract my, yeah, that's right. That's right. That's what I got. It's interesting that this, like I said, this roughly, 10 to the minus 3 newtons says 0.001 rough estimate, right? Real rough estimate. But apparently when you do the calculation, I'm looking at the answers that Mr. Wishway put at the end of the packet. He says that the value comes out to be 0.4 newtons And so that seems pretty far off. That's 10 to the minus 1. It's like 2 orders of magnitude off, which makes me wonder, how did that happen? How did I get so far off on my estimate? That's really, really unfortunate. And now I want to I want to do the actual calculation and see if I can figure out why my value is coming off is off by so much. 9 times 10 to the 9 times 8 times 10 to the negative 5 times 2 times 10 to the negative 5. Oh, well, there you go. 10, no, that's right. And then 6 squared. All right. What did I do? Oh, because this isn't squared. I went ahead and I did 10 times 10 to 10. See, that's an extra 2. That's not supposed to be there. That's why. That's what did it. Okay, that gives me 2. That gives me 10 to the minus 1. And you say, hey, that is exactly what we got. We got 0.4. And that'd be 0.1. That's the right order of magnitude. There we go. Okay, all good. Okay, shoo, I feel better.